Imagine walking outside tonight. You look up, and there are two moons. Not a dream, not an eclipse, not a reflection. Two real moons hanging above Earth. At first, it feels beautiful. The night is brighter, the sky feels larger, almost magical. But then, the oceans begin behaving differently. Tides stop following the patterns humanity has known for thousands of years. Animals that navigate by moonlight become confused. The length of Earth's day begins changing, almost too slowly for anyone to notice. And over millions of years, even the stability of our planet itself could be rewritten. It sounds like science fiction, yet throughout our solar system, having multiple moons is actually the rule. Mars has 2, Jupiter nearly 100, Saturn has even more. Compared to them, Earth is the unusual one. So what if that changed? What if somehow our planet gained a second natural moon? Would life simply continue beneath a more beautiful night sky? Or would this quiet companion slowly reshape our oceans, our climate, our wildlife, and even the passage of time itself? Tonight, we're not exploring a sudden apocalypse. Nothing crashes into Earth, nothing explodes. Instead, we'll follow something far more realistic and far more fascinating, a slow transformation, one that unfolds across thousands, millions, and even billions of years. Because adding a second moon wouldn't simply change what we see above us. It would quietly rewrite the rhythm of the entire planet. The oceans would move differently. Coastlines would slowly evolve. Ancient tidal cycles would become more complex. Some regions would experience floods unlike anything in recorded history. Others would become unexpectedly calm. Sea turtles, corals, migrating birds, countless species whose lives are synchronized with moonlight would all receive different signals. Many would adapt, some might not. Even Earth's rotation, already slowing ever so slightly, would follow a different path. Time itself would begin changing, one tiny fraction of a second at a time. And perhaps the greatest change wouldn't happen to Earth at all. It would happen to us. Every civilization in human history has shared the same moon. The same silent companion watched the pyramids rise, reflected across Viking seas, guided explorers, inspired poets, and welcomed the first humans to walk upon its surface. It has shaped our calendars, our myths, our religions, our imagination. Now imagine a world where there had always been two. Children would never question it. Artists would paint both. Sailors would navigate beneath both. Entire civilizations would build stories around the dance between these two silent worlds. The sky itself would become something entirely different. So tonight, dim the lights, get comfortable, and lift your eyes toward a sky humanity has never known as we explore what might happen if Earth had two moons.
The easiest change to notice would be the light. Tonight, our single moon reflects only about 12% of the sunlight that reaches it. Even so, it can illuminate mountains, cast shadows across deserts, and guide travelers through forests without a single artificial light. Now, imagine another moon joining it. Not necessarily as large as the one we know, perhaps only half its size, perhaps a little smaller. Even then, the night would rarely become truly dark. On some evenings, both moons would rise together. Their combined light would gently wash across the oceans, brightening valleys, fields, and city rooftops. The Milky Way, so breathtaking under today's darkest skies, would become harder to see. Astronomers living thousands of years ago, who relied entirely on naked eye observations, might have discovered fewer constellations. Some faint planets could have escaped notice for centuries. The history of astronomy itself might have unfolded differently. But brightness wouldn't remain constant. Unlike our single moon, two moons would almost certainly orbit Earth at different speeds. One might complete an orbit every 27 days, much like our current moon. The second, depending on its distance, could circle much faster or much slower. This means their positions would constantly change. Sometimes they would appear close together, creating spectacular twin moonrises. Sometimes one would rise just as the other set. Sometimes only one would be visible all night. And occasionally, both would disappear below the horizon at the same time, leaving behind the darkest nights anyone could experience. Those nights would become rare, almost special. Entire festivals might celebrate them. Children could grow up waiting for the few evenings when both moons finally vanished, revealing a sky overflowing with countless stars. Other nights, the opposite would happen. Both moons could become nearly full together. Imagine stepping outside. No streetlights, no flashlight, yet the landscape is bright enough to read a book. Your shadow appears clearly on the ground, perhaps even two faint shadows, each cast by a different moon from a different direction. It would feel unfamiliar, almost dreamlike. Photographers would treasure those nights. Artists would chase them. Poets would never run out of inspiration. Nature, however, would not experience this as simple beauty. For countless animals, darkness is information. Many species measure moonlight with astonishing precision. Tiny insects navigate by it. Owls use it while hunting. Bats adjust their behavior depending on lunar brightness. Predators often hunt more successfully during bright nights, while prey become far more cautious. With two moons, those ancient patterns begin to shift. Some nights would become brighter far more often than they are today. Nocturnal animals might spend less time searching for food. Others might avoid open spaces entirely. Evolution would slowly begin rewriting behaviors that have remained stable for millions of years. Sea turtles provide one remarkable example. Newly hatched turtles instinctively crawl toward the brightest horizon, which has traditionally been the moonlit ocean. Artificial lighting already confuses many hatchlings. Now imagine two moons appearing in different parts of the sky. Would young turtles always know which direction leads to safety? Perhaps over thousands of generations, they would adapt. Nature usually finds remarkable solutions given enough time. The oceans themselves would shimmer differently. Moonlight dances across waves because each ripple reflects tiny fragments of light. Two moons would create overlapping reflections, silver pathways stretching across the sea, sometimes crossing, sometimes separating, as though two invisible painters were brushing light across moving water. Sailors throughout history, accustomed to reading the ocean beneath one moon, would instead learn entirely different traditions. Every culture develops stories from the sky it inherits. Our ancestors imagined rabbits, faces, wolves, and goddesses within a single moon. Now imagine two celestial companions. Would one represent wisdom, the other adventure? Would one symbolize beginnings, the other endings? Perhaps one moon would be considered gentle, while the other earned a reputation for mystery. Entire calendars could be built around the moments when both became full together. Rare alignments might mark weddings, harvests, or sacred ceremonies. Even language itself would evolve differently. Instead of saying, "under the moonlight," people might ask, "which moon lit your journey?" It's fascinating how quickly something extraordinary becomes ordinary. If you were born beneath two moons, you wouldn't think of them as extraordinary at all. You might hear stories from another universe where Earth had only one moon and find the idea strangely lonely. That's one of the quiet lessons hidden inside astronomy. Normal depends entirely on where and when you happen to exist. As the years pass, humanity would adapt to brighter nights without much difficulty. Our cities would still glow, our telescopes would improve, life would continue. But beneath those peaceful skies, something far more powerful would already be beginning. Not in the heavens, not in human civilization, but deep within Earth's oceans. Because while moonlight shapes the night, gravity shapes the planet itself. And with two moons pulling on Earth, the sea would begin following an entirely new rhythm. Although, there is something even more fascinating than simply seeing two moons. The fact that you would almost never see the same sky twice. Our moon follows a beautifully predictable cycle. A thin crescent, a growing half moon, a brilliant full moon, and then the slow journey back into darkness. Every 29.5 days, the pattern quietly repeats. It's one of the oldest rhythms humanity has ever known. But introduce a second moon, and that rhythm disappears. Imagine one moon completing its orbit in 27 days, while the other takes 42. They begin together, but they never stay together for long. Night after night, their relationship changes. One evening, both moons rise side by side. They appear almost like twin worlds, sharing the same path across the heavens. The next week, they're separated by half the sky. One is already high above you, while the other has only just begun climbing over the horizon. Another week passes. One becomes a brilliant full moon, the other only a delicate crescent. The contrast would be breathtaking. Half the sky glowing with brilliant silver light, while the second moon hangs quietly nearby, a thin curve of pale white.
Some nights, one moon wouldn't rise until hours after the other had already set. For a short time, the world would briefly resemble our own, only one moon watching over the earth. Then, slowly, a second glow would appear above the horizon, a reminder that this world was never quite the same. No calendar could truly prepare you for every combination, because the two cycles would constantly overlap in new ways. Two crescents, two half-moons, a full moon beside a delicate crescent, a full moon beside another full moon, sometimes both nearly invisible, sometimes both dazzlingly bright. The number of possible skies becomes astonishing. An artist could paint the night every evening for an entire lifetime and almost never repeat the same composition. Ancient civilizations would quickly begin searching for meaning. Human beings have always found stories in the sky. The stars became heroes, constellations became animals, the moon became gods, spirits, guardians, and symbols of time itself. Now imagine giving humanity not one celestial companion, but two. Perhaps one moon becomes associated with peace, the other with courage. One marks the beginning of planting season, the other announces the coming of winter. Children grow up learning stories about both. Parents point toward one moon, telling tales of kindness, then gesture toward the other, where brave explorers supposedly began their endless journey across the heavens. Entire religions might develop around the dance between the two. Moments when both become full together could be celebrated as sacred nights. Rare alignments, occurring only once every few years, might become festivals lasting days. Cities fill with lanterns. Families gather beneath the brightest skies of the year. Not because science tells them to, but because every culture builds traditions from the universe it inherits. Even eclipses become far more spectacular. Today, a solar eclipse is already one of nature's greatest performances. The moon slowly covers the sun. Day briefly becomes night. Birds fall silent. Temperatures drop. The stars appear in the middle of the afternoon. Now imagine two moons. Perhaps the smaller moon crosses the sun first. Hours later, the larger one follows. Or perhaps one moon partially covers the sun, while the second never reaches it at all. Every eclipse becomes unique. Astronomers would spend lifetimes predicting these celestial dances. Entire expeditions would travel across continents simply to witness one especially rare alignment. Then there are the moments almost impossible to imagine. One moon passing directly in front of the other. From Earth, you would watch one world slowly glide across another. Two enormous celestial bodies moving with almost impossible precision. No explosion, no collision, only silent motion. A reminder that gravity never sleeps. Photographers would wait years for these events. Children would remember them forever. Some people might never witness one during their lifetime. Others, by pure chance, step outside on exactly the right evening. It's extraordinary to think that our own moon already shapes so much of our imagination. Now double that influence, double the stories, double the symbolism, double the wonder. People often assume astronomy is mostly about numbers, distances, masses, equations. But before astronomy became science, it was simply people looking upward, wondering, dreaming, trying to understand why the sky looked the way it did. Two moons would not merely change physics, they would reshape human imagination itself. Every language would develop new expressions, every civilization new myths, every generation new memories, and every child would eventually ask exactly the same question. Which moon is your favorite? Perhaps everyone would have an answer, not because one was objectively more beautiful, but because each moon would slowly become part of who they were, a familiar companion, a silent presence, always changing, yet always returning. And while humanity filled the heavens with stories, something far less poetic was already beginning far below, invisible to every eye, hidden beneath the endless surface of the sea. Because the oceans don't care about legends, they only answer one language: gravity.
But the sky wouldn't be the only thing that changed. Time itself would begin to feel different. Not because the hours became longer, or because Earth suddenly spun faster, but because humanity has always used the moon to measure the passage of time. Long before mechanical clocks, before calendars, before written history, people looked upward. The changing face of the moon became one of nature's first calendars. A crescent meant the beginning of a new cycle. A full moon marked another. Entire civilizations learned to plant, harvest, travel, and celebrate according to those familiar phases. Now imagine trying to build a calendar with two moons. At first, it sounds impossible. Which moon do you follow? The larger one, the brighter one, the faster one, or both? Different cultures might answer that question differently. A civilization living beside the ocean, where tides determine survival, might choose the moon with the strongest gravitational influence. A farming society, more interested in seasonal rhythms, might instead follow the moon whose cycle aligned most closely with the changing climate. Within only a few centuries, the world could be filled with entirely different calendars. Not because people disagreed, but because the sky itself offered more than one rhythm. Imagine two neighboring kingdoms, only a few hundred kilometers apart. One celebrates the new year beneath the first full moon, the other waits for the second. Their festivals never occur on the same night. Their holidays slowly drift apart. Even birthdays become surprisingly complicated. Someone might ask, were you born during the great moon's fifth cycle or the silver moon's eighth? Both answers would describe the very same day, just through different ways of measuring it. Navigation would evolve as well. For thousands of years, sailors relied on the stars and the moon. Every familiar object in the sky became a trusted guide across open water. A second moon introduces an entirely new celestial reference point. Experienced navigators could estimate direction, time, and even approaching tides simply by comparing the positions of both moons. On cloudy nights, they might patiently wait for just one moon to emerge, already knowing exactly where the second should be. The relationship between them becomes a compass of its own. Explorers crossing vast deserts, travelers moving through frozen wilderness, even nomadic tribes would eventually master this new language of the sky. It wouldn't seem extraordinary. It would simply be another skill passed from one generation to the next. Stories would change too. Think about how often our own moon appears in literature. A lonely moon, a silent moon, a watchful moon.
Now imagine every storyteller having two celestial characters instead of one. Perhaps one moon always represents hope, the other, memory. One watches over travelers, the other protects those waiting at home. Children listening beside evening fires would hear endless tales explaining why the two moons sometimes drift close together. Perhaps they were siblings, perhaps lifelong friends, perhaps eternal rivals. Every culture would create its own answer, none scientifically correct, yet all deeply meaningful. Language itself slowly adapts. Instead of saying "once in a blue moon," people might invent entirely different expressions. When the twin moons meet, when both moons smile, when the western moon overtakes the eastern. Simple phrases, understood by everyone, lost forever to anyone from our world. Poetry would flourish beneath such skies. Artists often search for contrast, light and shadow, joy and sorrow, beginning and end. Two moons naturally invite those comparisons. Painters fill their canvases with silver reflections dancing across lakes. Musicians compose melodies inspired by evenings when both moons rise together. Architects design temples with twin towers, each aligned to a different lunar path. Even love stories change. Imagine two people separated by great distance. One looks toward the larger moon, the other watches the smaller, both knowing that somewhere beyond the horizon, the other person is looking at the very same sky. Different moon, same night. Small ideas like these quietly shape civilizations, not through science, but through emotion. Because humans rarely remember equations, we remember stories, we remember symbols. We remember the feeling of looking upward and believing that the universe is speaking directly to us. Perhaps that's why every civilization, no matter how advanced, continues searching the heavens, not only for answers, but for meaning. And while humanity built myths, songs, and calendars beneath its two silent companions, gravity continued its patient work, far beyond what anyone could see, because the greatest influence of two moons would not be found in our stories. It would be written slowly across the planet itself. There is another consequence, one so subtle that most people would never think to ask about it. Shadows. Right now, every shadow you see beneath the moon comes from a single source of light. One moon, one direction, one soft outline stretching quietly across the ground. But with two moons, the night becomes far more mysterious. Imagine walking through a quiet forest. The wind barely moves. The leaves whisper above you. One full moon hangs low in the eastern sky. The second, only half full, rests high in the south. As you walk, your shadow doesn't simply follow behind, it splits. A darker shadow stretches one way. A softer, fainter shadow reaches another. Every tree casts two silhouettes. Every mountain leaves overlapping shapes across the valley. Even your own footsteps seem surrounded by ghostly echoes. At first, it would feel almost unsettling, your eyes constantly trying to understand which shadow belongs to which moon. But children born into this world would never question it. To them, a single shadow would seem strangely incomplete. Artists would quickly discover endless possibilities. Moonlight paintings, already admired for their quiet beauty, would become even more dramatic. One moon illuminating a castle from the left, the other gently outlining its towers from behind. Depth, texture, contrast. Entire artistic movements might emerge from nothing more than the direction of moonlight. Photographers would wait patiently for rare nights when both moons reached exactly the right positions, one creating soft highlights, the other revealing details hidden in darkness. No artificial lighting, only the sky itself painting the landscape. Snow-covered mountains would become especially breathtaking. Fresh snow reflects moonlight with surprising efficiency. Two moons shining across an untouched valley could make the landscape glow with an almost unreal brightness. A frozen lake might mirror both moons simultaneously. Above, two perfect circles. Below, their shimmering reflections dancing across the ice. It would feel less like Earth and more like another world entirely. The desert would offer its own spectacle. Sand dunes are shaped by light. Long shadows reveal every ripple carved by the wind. With two moons, those ripples would appear almost three-dimensional. One set of shadows emphasizing one side of every dune, the second revealing features invisible beneath only one light source. Travelers crossing the desert at night might see landscapes that appear to change shape, simply because one moon slowly rises while the other slowly sets. Even forests would transform. Moonlight filtering through thousands of leaves already creates beautiful patterns. Now imagine two beams of pale light arriving from different angles. The forest floor becomes a living mosaic. Tiny patches of silver constantly shifting as both moons continue their slow journey across the sky. No two nights would ever look exactly alike. Clouds, too, would become more dramatic. On nights with a single moon, clouds often glow along one edge. With two moons, each cloud might carry two separate silver linings, one brighter, one softer, sometimes merging, sometimes pulling apart. Storm clouds would appear almost sculpted, towering walls of illuminated vapor stretching across the horizon. Even rain would look different, every falling drop reflecting two tiny points of light, countless diamonds descending through the darkness. The sea, already transformed by changing tides, would now shimmer with two separate paths of silver, sometimes crossing one another, sometimes drifting apart. Sailors might call them the twin roads of light, one leading east, the other west. Perhaps entire legends would claim that following one path brings fortune, while following the other invites mystery. Science would know the truth, but stories have never needed physics to survive. Perhaps the greatest surprise is this: none of these changes make the night frightening, only unfamiliar. Human beings adapt remarkably quickly. What feels impossible today often becomes ordinary within a single generation. After a few decades, people would stop noticing the double shadows. Children would run beneath them without a second thought. Artists would simply call them shadows, no special word required. Because that's what normal always becomes. The extraordinary, seen often enough, quietly transforms into everyday life. And while humanity admired the beauty above, another invisible transformation continued below. Not in the oceans this time, not in the sky, but within the planet itself. Because two moons would not merely pull on the sea, they would tug ever so gently on the solid earth beneath our feet.
It's easy to forget that Earth is not perfectly solid. It feels immovable beneath our feet. Mountains appear eternal. Continents seem fixed in place. But our planet is constantly moving. The crust slowly bends. The mantle quietly flows. Even the hardest rock responds, ever so slightly, to gravity. Right now, our own moon doesn't only pull on the oceans, it also lifts the land itself. Scientists call these Earth tides. Unlike ocean tides, they're almost impossible to notice without precise instruments. Yet the ground beneath your feet rises and falls by several centimeters each day. The entire planet breathing, so slowly that no human being can ever feel it. Now imagine adding another moon. Suddenly, Earth is responding to two gravitational rhythms instead of one. The surface continues its silent rise and fall, but no longer with the same simple pattern. Sometimes both moons pull together. The crust flexes just a little farther. Sometimes they pull from different directions. One side of the planet gently stretches, while another relaxes. The difference remains tiny, measured in centimeters, not meters, certainly not kilometers. You would never wake up and feel the ground moving beneath your bed. Life continues exactly as before. Yet, over immense spans of time, even tiny forces matter. Our planet is remarkably sensitive. Pressure changes deep underground can influence where stress accumulates along faults. Could two moons trigger more earthquakes? Probably not in the dramatic way movies often imagine. Earthquakes are driven primarily by tectonic plates, continents slowly grinding against one another over millions of years. The additional pull from a second moon would not suddenly tear the planet apart, but in certain places where enormous stress already exists, those gentle gravitational nudges might slightly influence the timing of an earthquake that was already destined to occur. Not creating it, simply encouraging it to occur a little earlier or a little later. Nature often works this way, small influences acting upon larger systems. Volcanoes tell a similar story. Deep beneath Earth's surface, molten rock is constantly searching for pathways upward. Most magma never reaches daylight. Some does. Could changing gravitational forces affect volcanic activity? Perhaps, very slightly. Researchers today still investigate whether lunar tides subtly influence certain volcanic systems. The evidence remains limited. With two moons, those effects could become somewhat stronger, though still incredibly small compared with the immense energy stored inside Earth's mantle. The true story is not one of catastrophe, it's one of constant adjustment. Our planet quietly responding, day after day, to a more complicated gravitational dance. Even caves might slowly record this invisible rhythm. Tiny mineral deposits grow drop by drop over thousands of years. Perhaps future geologists studying ancient cave formations would discover repeating patterns left behind by two moons that once circled Earth together. The rocks themselves preserving a calendar written in stone. The same could happen in coral skeletons, ancient shells, tree rings, even layers of ocean sediment. Nature keeps extraordinary records. Long after civilizations disappear, the planet remembers. Every season, every climate shift, every subtle change in gravity. Millions of years from now, scientists from another civilization might uncover those clues. Without seeing the moons themselves, they could still reconstruct their existence simply by reading Earth's geological memory. There is something quietly beautiful about that idea. The universe leaves signatures everywhere, not written in words, but in patterns, in stone, in ice, in the slow movement of continents. Nothing happens completely in secret. Given enough patience, nature always tells its story. And perhaps that is the greatest difference between human history and planetary history. We remember centuries, Earth remembers eons. While generations come and go, the planet continues recording every passing orbit, every shifting tide, every gentle pull from the heavens. Page after page, written across billions of years. And eventually, those countless tiny changes would shape something even larger, not just the ground beneath our feet, but the climate of the entire world. Because when gravity changes, even slightly, the future of a planet can slowly change with it. The ocean has no memory. It doesn't remember yesterday's waves or last year's storms. It simply responds to the forces acting upon it at this very moment. Every hour, every minute, the sea is quietly answering one invisible question. Where is the moon? Its gravity reaches across nearly 400,000 kilometers, gently pulling on every drop of water covering our planet. Not enough to lift the oceans into the sky, but enough to create a slow, continuous swell. One bulge forms on the side of Earth facing the moon. Another appears on the opposite side, created by the balance between Earth's motion and the moon's gravity. As our planet rotates beneath these bulges, coastlines experience what we simply call the tides. Most of us hardly notice them. The beach looks a little different in the morning than it did the evening before. Fishing boats rise and fall. Marshes flood, then empty again. It feels almost routine, but tides are among the largest recurring movements of water anywhere on Earth. Every single day, billions upon billions of tons of seawater quietly shift around the globe. Now imagine introducing another moon, another source of gravity, another invisible hand gently tugging at the oceans. At first, you might expect every high tide to simply become twice as large, but nature is rarely that simple. Gravity doesn't merely add together, it combines, sometimes strengthening itself, sometimes partially canceling itself, sometimes creating patterns far more complicated than either force alone. Picture two people pushing a child on a swing.
If they push together, the swing climbs higher. If they push at different moments, the motion becomes irregular, sometimes stronger, sometimes weaker, sometimes almost chaotic. Earth's oceans would behave in much the same way. Whenever both moons lined up on the same side of Earth, their gravitational pulls would reinforce one another. High tides could become noticeably higher than anything we regularly experience today. Not towering walls of water, but persistent surges arriving with remarkable consistency. Low-lying coastlines would slowly adapt. Salt water would travel farther inland, marshes would expand. Certain beaches might disappear altogether. Communities living near the sea would eventually build differently, not because of one catastrophic flood, but because the ocean had quietly claimed a little more land every year. Then, a week or two later, the moons might move into very different positions. Instead of pulling together, they would pull from different directions. One moon lifting water toward the east, the other gently encouraging it toward the south. The familiar rhythm of high tide, low tide would become far more complicated. Some coastlines could experience 3 significant tides each day, others perhaps 4 smaller ones. The timing would vary constantly. Ancient fishermen who once knew exactly when the sea would rise would need entirely new calendars. Ports around the world would redesign their schedules. Harbors would become engineering puzzles. Every lighthouse keeper, every sailor, every coastal village would learn to read 2 celestial clocks instead of 1. Some places would benefit. Tidal energy, already one of the cleanest forms of renewable power, might become dramatically more productive.
Regions with powerful tidal currents could generate electricity day and night with even greater efficiency. Entire civilizations might develop around these predictable flows. History often follows energy. A different ocean could lead to a different technological world. Beneath the surface, the changes become even more interesting. The oceans are not still bodies of water. They constantly mix. Warm water drifts toward the poles. Cold water sinks and slowly returns toward the equator. This immense circulation, sometimes called Earth's global conveyor belt, helps regulate our climate. It transports heat around the planet, making many regions far more comfortable than they would otherwise be. Tides contribute to that mixing, not by themselves, but as part of a vast and interconnected system. If tidal patterns changed, ocean circulation could slowly change with them. Not overnight, not within a generation, but over thousands of years. Some coastal waters might become richer in nutrients, others less productive. Entire fisheries could gradually move. Marine ecosystems, which often appear timeless, would quietly rearrange themselves. Coral reefs provide one beautiful example. Many coral species release eggs and sperm simultaneously, timing these remarkable events using the phases of the moon. For just a few nights each year, entire reefs reproduce together. The water becomes filled with tiny drifting clouds of new life. Scientists still marvel at how precisely these events are synchronized. Now imagine 2 moons, each following its own cycle. Would coral choose one moon, both, a completely new rhythm? No one can say for certain. But evolution has always been an extraordinary problem solver. Given enough generations, life almost always finds a way. Whales, too, might experience a different ocean. Many migrate thousands of kilometers each year. They navigate using sound, magnetic fields, currents, and perhaps even subtle environmental rhythms we are only beginning to understand. A changing tidal world could gradually reshape their migration routes. not because the whales consciously choose differently, but because the oceans themselves would slowly become different places. Even the sound of the sea might change. Tides generate currents. Currents shape waves. Waves sculpt coastlines. The familiar rhythm of water washing against the shore, one of the oldest sounds on Earth, could develop new patterns. Some beaches might become quieter, others more energetic. Sea caves would sing different notes as water entered and escaped. Rock formations would erode along new paths. Given enough time, entire coastlines would almost become unrecognizable. Yet if you visited this world after millions of years, none of it would seem unusual. Children would build sand castles on beaches that had always existed. Families would plan holidays around tides that had always followed two moons. Sailors would learn charts that reflected an ocean unlike our own. Everything would feel perfectly normal, because every generation inherits the world as it is, not as it once was. And while humanity adjusted to changing coastlines, another transformation would already be unfolding, one that reached far beyond the oceans, into forests, grasslands, mountains, and deserts. Because moonlight does far more than illuminate the night. For countless living creatures, it quietly keeps time. For most of human history, the moon has quietly controlled Earth's tides. Twice each day, entire oceans rise, then fall, pulled by a force we rarely notice. It's so familiar, we hardly think about it. But add a second moon, and the sea begins following two masters instead of one. At first, nothing seems alarming. There are still high tides, still low tides, but they no longer arrive with the comforting regularity our world depends upon. Because each moon moves through the sky at its own pace, their gravitational pulls constantly combine, then oppose one another. Sometimes both moons pull in nearly the same direction. Their gravity adds together. High tides become significantly higher than anything coastal communities experience today. Storm surges suddenly travel farther inland. Harbors flood more often. Waves reach places they never touched before. Then, only days later, the opposite happens. The moons pull against each other. One lifts the ocean while the other partially cancels that force. The tides weaken dramatically. Some coastlines barely notice the sea moving at all. The rhythm becomes unpredictable, powerful, complicated, and Earth must adapt. Around the world, countless ecosystems depend on tidal timing. Mangrove forests, salt marshes, coral reefs, shellfish beds. Entire food chains are synchronized with the rising and falling sea. Many fish release their eggs during specific tides. Crabs emerge at precise moments. Birds know exactly when shallow waters expose food beneath the sand. Nature has spent millions of years perfecting this schedule. Now, the schedule changes. Some species would struggle. Others might disappear. But evolution rarely leaves empty spaces for long. New behaviors would emerge, new migration patterns, new breeding cycles. Life would slowly learn the rhythm of two moons. Humans, however, would face immediate challenges. Many of the world's largest cities were built beside oceans: New York, Tokyo, Shanghai, London, Mumbai, Alexandria. Their ports, bridges, flood barriers, and coastlines were designed around today's tides. A stronger, less predictable tidal system would force engineers to rethink nearly everything. Seawalls grow taller, harbors are redesigned, flood maps are rewritten. Entire neighborhoods might eventually relocate inland, not because the sea level permanently rises, but because the sea refuses to behave the way it once did. Shipping becomes more difficult. Captains have always planned departures around predictable tides. Now those calculations become far more complicated. Some ports may only remain usable during certain alignments of the moons. Others require entirely new infrastructure to keep trade moving safely. Even renewable energy changes. Today, many countries harvest electricity from tidal motion. With stronger tidal extremes, those power stations could produce far more energy, but only if engineers manage to survive the violent conditions created by the shifting currents. Beneath the surface, the oceans themselves begin changing. Tides do far more than move water along coastlines. They stir the deep sea. They carry oxygen downward. They transport nutrients upward. This invisible circulation feeds microscopic plankton, which feed fish, which feed nearly everything else. Change the tides, and eventually you change the entire marine food web. Some regions could become richer than ever before. Others, surprisingly, might become biological deserts. Weather begins responding too. The oceans store enormous amounts of Earth's heat. As currents shift, heat moves differently around the planet. Some coastlines become wetter, others become unexpectedly dry. Storm tracks slowly migrate. Entire climate zones drift over centuries. Not overnight, not dramatically, but enough that civilizations gradually follow the changing environment. Farmers plant different crops. Forests expand into new regions. Deserts slowly creep across places that were once fertile. Human history, once again, takes a different path. Yet, despite all these changes, Earth remains alive. Cities adapt. Animals evolve. Children born beneath two moons never think of any of this as unusual. To them, complex tides are simply how oceans behave. That's the remarkable resilience of life. Given enough time, it reshapes itself around almost any challenge. But one question still remains. Could two moons peacefully share Earth's sky forever? Or would gravity slowly, patiently, turn this beautiful celestial dance into a disaster waiting millions of years to happen?
The answer depends on one simple detail. Where did the second moon come from? If it formed alongside our current moon and settled into a stable orbit, then perhaps the two could coexist for billions of years. Astronomers already know that nature can build surprisingly stable systems. Some planets have many moons. Some stars have multiple suns. Gravity, despite its reputation for chaos, often finds balance. But balance does not mean stillness. Every orbit slowly changes. Every gravitational tug leaves a tiny fingerprint. Month after month, century after century, million after million of years. Neither moon would travel through space completely unaffected. Each would constantly pull on the other, sometimes speeding it up, sometimes slowing it down, sometimes altering its orbit by only a few centimeters. Tiny changes, almost impossible to notice until enough time passes. Imagine pushing a playground swing. One gentle push changes almost nothing. Thousands of perfectly timed pushes can transform a gentle motion into something enormous. Gravity works much the same way. Eventually, one moon could drift slightly farther away or slightly closer. Its orbit might become more elliptical. Instead of tracing a nearly perfect circle, it begins stretching into an oval. At first, the distance is invisible, but slowly, its distance from Earth changes more dramatically each month. One month, it appears unusually large. Months later, surprisingly small. The tides become even more unpredictable. The night sky itself changes shape from season to season. If the orbital resonance becomes unstable, something even stranger can happen. The moons begin exchanging energy. One gradually steals orbital momentum from the other. One climbs outward, the other spirals inward. Not quickly, not over human lifetimes, but over geological time, the dance slowly falls out of step. What happens next depends on countless variables. One possibility is surprisingly peaceful. The outer moon continues drifting away until Earth's gravity can no longer hold it. It quietly escapes into its own orbit around the sun. Our planet returns, once again, to having a single moon. Future civilizations might discover strange rocks in space, the ancient companion that once illuminated Earth's nights. Another possibility is far less gentle. If one moon gradually moves closer, Earth's gravity grows stronger with every passing orbit. Eventually, it crosses an invisible boundary, known as the Roche limit. Beyond this point, gravity no longer allows a moon to remain whole.
Earth's tidal forces become stronger than the moon's own gravity. The surface begins cracking, mountains collapse, great fractures spread across the landscape. Slowly, the moon tears itself apart, not in a fiery explosion, but in silence. Gigantic pieces continue orbiting Earth, then smaller fragments, then countless rocks forming an enormous ring around our planet. For a time, Earth would resemble Saturn, a brilliant ribbon of ice and stone stretching across the heavens. It might become the most beautiful sky any human has ever seen. But beauty often hides danger. Some fragments gradually fall toward Earth. Most burn harmlessly in the atmosphere. Others survive. Meteor showers become common. Occasionally, larger impacts remind humanity that celestial mechanics are never completely gentle. Yet even this dramatic ending would unfold across immense stretches of time. Thousands, perhaps millions of years. Not something civilizations would witness in a single generation. More likely, they would simply inherit a slowly changing sky. Children would ask why ancient paintings showed two moons while their own nights displayed a glowing ring. Historians would preserve the memory. Scientists would explain the physics. Poets would mourn what was lost. And life, as always, would continue beneath whatever sky remained. There is another fascinating consequence. Our moon currently stabilizes Earth's axial tilt. Without that stabilizing influence, Earth's poles could wander far more dramatically over millions of years. Two moons working together might stabilize our planet even better. Or, if their gravitational effects conflict, they could make Earth's rotation less predictable. Tiny changes in axial tilt influence seasons. Over immense timescales, entire climate patterns could shift. Ice ages may arrive differently. Rain belts migrate. Forests advance and retreat. Again, not because of catastrophe, but because gravity quietly rewrites the rules. It is remarkable how much of our world depends upon objects that seem so distant. The moon appears peaceful, silent, unchanging, yet without it, Earth already would be a profoundly different planet. Adding just one more changes nearly everything. Not instantly, not violently, but patiently, one orbit at a time, one tide at a time, 1,000,000 years after another. And perhaps that is the greatest lesson hidden within this thought experiment. The universe rarely transforms worlds in a single dramatic moment. More often, it changes them through countless tiny forces, acting faithfully, day after day, until an entirely new world quietly appears. This brings us to the final chapter, not about destruction, not about survival, but about perspective. Because after imagining a sky with two moons, we may begin to see the single moon above us very differently.
After everything we've imagined, there is one final question worth asking. Could any of this have actually happened? Surprisingly, not entirely, but not entirely impossible either. Astronomers have already discovered planets with astonishing families of moons. Some giant planets in our own solar system host dozens. In fact, Saturn alone has well over 100 known moons. To the universe, having many moons is nothing unusual. What's unusual is a small rocky planet like Earth having two large moons of comparable size. Could Earth have captured one? Gravity does occasionally steal wandering objects. Small asteroids become temporary moons. In fact, Earth has already done this. From time to time, tiny space rocks are briefly captured by our planet's gravity. They orbit Earth for a few months, sometimes a few years, before quietly escaping back into space. Astronomers call them temporary mini-moons. But capturing something as massive as our moon is a completely different challenge. A body that large carries an enormous amount of energy. Without some way to slow it down, it simply flies past Earth, continuing its endless journey around the Sun. For a permanent capture to occur, an extraordinary sequence of events would be required. Perhaps another massive object steals away just enough energy. Perhaps a rare three-body interaction unfolds with almost impossible precision. The laws of physics don't forbid it. They simply make it extraordinarily unlikely. There is another possibility. Perhaps Earth didn't capture a second moon at all. Perhaps it formed with one. Some scientists have explored the idea that after the giant impact which created our moon, more than one large fragment may have entered orbit around the young Earth. Instead of a single newborn moon, there could briefly have been two. Over millions of years, those worlds might have slowly interacted. Eventually, one merged with the other, or one was thrown away into space, leaving behind the lone companion we know today. Interestingly, some researchers have even proposed that hidden within our moon itself, there may be evidence of such an ancient collision. As if, long before human beings ever looked upward, two moons may have become one. Whether that idea is correct, scientists continue to investigate. That's one of the beautiful things about astronomy. The universe is under no obligation to match our expectations. Every decade, new discoveries reshape what we thought was possible. Planets orbiting two stars, worlds wandering through space without any star at all, moons hiding oceans beneath frozen ice. The cosmos has repeatedly proven that imagination often falls short of reality. Perhaps somewhere, many light years from Earth, there truly is a quiet blue world, its oceans breathing beneath the pull of two moons, its forests glowing beneath twin moonlight, its children growing up believing that every planet in the universe must surely have two moons. And perhaps, on one peaceful evening, one curious child looks toward the sky and wonders what it would be like to live on a strange little world with only one. It's a gentle reminder that normal is a matter of perspective. Every civilization believes its sky is ordinary until it imagines another. And perhaps that's the greatest gift of thought experiments like this. They don't change the universe, they change the way we see it. Which brings us to the final chapter. Not about gravity, not about astronomy, but about perspective.
For the last hour, we've imagined a different Earth, a world with two moons, a world where the oceans breathe to a different rhythm, where the night is brighter, where calendars, cultures, animals, and even history quietly unfold along another path. And yet, through all those changes, one thing remained remarkably familiar. Life endured. People still watched sunsets. Children still played beneath the evening sky. The waves still reached the shore. The stars, though sometimes hidden by brighter moonlight, were still there. Perhaps that's the most comforting discovery of all. When we imagine the universe, it's easy to picture catastrophe, exploding stars, colliding planets, cosmic disasters unfolding without warning. But the universe is usually much quieter than that. Most change happens patiently. A mountain rises 1 millimeter at a time. A continent drifts no faster than your fingernails grow. A galaxy rotates so slowly that no human lifetime can ever witness its motion. Even the moon, our constant companion, is already leaving us. Every year, it drifts away from Earth by about 3.8 centimeters, roughly the width of 2 fingers. You'll never notice it. Your children won't notice it, nor will their grandchildren. But if enough time passes, the distance becomes enormous. Hundreds of millions of years from now, total solar eclipses will disappear. The moon will simply appear too small to completely cover the sun. Without realizing it, we already live inside a changing universe. The changes are simply too slow for us to see. Perhaps that's why the night sky feels so permanent. We measure life in decades. The universe measures life in billions of years. Those are very different clocks. If Earth had been born with 2 moons, we would almost certainly consider them perfectly ordinary. Artists would paint them, scientists would study them, children would count them before going to sleep. Poets would write about the evenings when both appeared together. And if someone somehow described a distant world, a strange little planet with only 1 moon, many people might smile and wonder how lonely such a sky must feel. Normal is simply what we inherit. Nothing more, nothing less. Our own moon has quietly shaped nearly everything around us. Its gravity steadies Earth's gentle tilt. It slows our planet's rotation. It lifts the tides. It influences ecosystems.
It has inspired myths, music, paintings, stories, and scientific discoveries for thousands of years. It has watched every civilization that has ever existed, every language ever spoken, every question humanity has ever asked. It was there before the first city. It will likely remain long after the last one. Sometimes the most familiar objects are also the most extraordinary. We stop noticing them simply because they never seem to leave. Perhaps tonight, or the next time you step outside after sunset, you'll glance upward for just a moment. You'll see only one moon, exactly as generations before you have seen, exactly as generations after you probably will. And perhaps, for the first time, that single pale light will feel just a little more remarkable, because now you know how different our world might have been, how delicately balanced it truly is, and how countless invisible forces working together have quietly created the home we sometimes take for granted. The universe doesn't need to be loud to be astonishing. Sometimes its greatest wonders arrive in silence. A single moon crossing a peaceful sky, a gentle tide rolling onto an empty shore, a beam of pale light falling across a sleeping world. As our journey comes to an end, there is nothing more to imagine, nothing more to solve, only the quiet rhythm of the night continuing exactly as it has for millions of years. So allow your thoughts to drift as slowly as the moon itself crossing the heavens. Let every breath become a little softer, every sound a little farther away. There is nowhere else you need to be, nothing left to understand. Only the calm reminder that we are tiny travelers living for a brief moment beneath an ancient sky. Thank you for spending this quiet journey through the universe with me. Now I'll leave you with nothing but the gentle sounds of space, the soft whisper of the night, and the peaceful feeling of a familiar moon keeping its silent watch above the earth.
The story may be over, but the journey doesn't have to end here. From this point on, you'll hear only continuous brown noise blended with a gentle space ambiance. No more narration, no interruptions, just a calm, steady soundscape designed to help you relax, focus, study, meditate, or simply fall asleep. If you'd like, you can leave the video playing as long as you need. Thank you for spending this time exploring the universe with us. Sleep well.